Good morning. I'm Natasha and I'm here with Joyce and Paula. Ode to science and our cool physical appearance, we are a band of traveling fortune tellers and we're here to tell you about your future. You may not know it, but all of you have cancer and are going to die. Thankfully, to prolong your death, Marie Curie, Nobel Prize winning physicist and chemist, discovered radium and polonium, which have many applications and uses in oncology treatment today. Today we will be presenting Marie Curie, her discoveries of radium and polonium, and her Nobel Prize. Marie Curie not only made contributions in chemistry, but made strides in both society and medicine. Her discovery of radioactive elements and development of the concept of radioactivity changed the course of science forever. Likewise, her presence in the laboratory advanced rights for women's education and inspired a fleet of women scientists. Curie also improved treatments for the soldiers of World War I, and X-rays, cancer treatments, and nuclear medicine are all prevalent aspects of healthcare today. The goals of our presentation is to provide you with a background on Marie Curie, her contributions to chemistry, and the applications of those contributions.
Marie Curie made many significant contributions to the field of chemistry and physics that made her a legend both as a person and a woman. But who was she? Marie Curie was a Polish woman who lived in Warsaw from the late 19th to early 20th century. She got her primary education, but was barred for being a woman from pursuing higher education. She, however, entered into an underground school to continue her studies, and this was only the beginning of her career. While attending the underground school, she also worked as a governess and a tutor, and raised enough money to pay for her education at the reputed Sorbonne University in France. There she lived mostly on bread and tea, and worked alongside her husband until his death, researching mainly in interest of radioactive elements. While she worked alongside her husband, and their mutual interest gave way to mutual work, the fact that Marie was a woman in the 20th century kept her from getting the same mutual recognition she deserved. There are many instances where Marie experienced sexism in her career as a scientist. One of the most blatant ones being her almost exclusion from the Nobel Prize in 1903, which would have been awarded to just her husband and Becquerel had it not been for her husband stepping up for her. But even before receiving the prize, and after having received her PhD from the University of Paris, she and her husband were invited to the Royal Institution in London, and she was prohibited from speaking, so her husband gave the talk. And yet another instance includes her being welcomed from a very important scientific conference which included multiple Nobel laureates by an angry mob which crowded her house because of a scandal. However, regardless of all these uncomfortable circumstances, Marie made major strides in the sciences, not only for women. When her husband died, she was offered his position as a faculty at Sorbonne University. During the time she studied the nature of what she later coined as radioactivity, she made various discoveries that helped ground a better understanding of the atom and its components.
Throughout her lifetime, Marie Curie did a lot of work in the lab. Two of her main contributions to chemistry are the discovery of polonium and later the discovery of radium. Before these discoveries, it was assumed that uranium was the only active element. However, it was found that components like chalcolite were more active than uranium metal, suggesting that there exists a compound that is more active than uranium is in chalcolite. Thus, Marie Curie decided to work with the mineral pitchblende, which was also found to be more active than uranium metal, to isolate individual elements in an attempt to find an element that is more active than uranium. This led her to the discovery of polonium, which is 2.5 times more active than uranium, and later on also radium. Ultimately, these groundbreaking discoveries led Marie Curie to win 2 Nobel Prizes. In 1903, Curie won her first Nobel Prize in physics for discovering radioactivity. Previously, it was assumed that uranium was the only element that was radioactive, but Curie was able to show that there are other elements that are also radioactive. In 1911, Curie also won the Nobel Prize in chemistry for documenting the properties of radioactive elements and their compounds. By characterizing radioactive elements by their various properties, Curie was able to show that radioactivity is correlated with the element's mass. There is no doubt that Marie Curie made a big impact in the fields of chemistry through her discoveries, but these discoveries are still continuing to impact us today. After the discovery of radium, it was used in various capacities. In the early 1900s, radium was thought to be a cure-all, so it was included as an additive in many everyday products like toothpaste and water. Additionally, radium bromide was used to make luminous paints, where it was used to paint wash dials so that they would glow in the dark. At this point, the harmful effects of radium were still unknown. However, we now know that radium exposure is harmful, so radium is no longer used in these ways. One current use of radium is in cancer treatments, primarily for prostate cancer. Xofigo is a radioactive isotope of radium that goes directly into the bones where the cancer is, and it releases alpha particles. These alpha particles kill nearby cells by making double-strand breaks in the DNA. Xofigo is injected into the bloodstream and then naturally flushed out of the body with other waste. It emits low levels of radiation that travel less than 100 microns, making it a preferred form of cancer treatment because of its specific targets. Polonium also has many applications today. Polonium can be used as a static eliminator. When machines are working, they can emit electrons that cause the air surrounding them to be staticky. Polonium, which emits alpha particles, is able to neutralize the air by combining with electrons to form helium. Polonium is also a heat source that is often used in space missions. 1 gram of polonium produces 137 watts of energy, and half a gram of polonium can reach up to 500 degrees Celsius. Polonium is also a neutron source, making it useful in nuclear weapons. In a polonium-beryllium pair, beryllium absorbs alpha particles emitted by polonium, and in this process, it also releases neutrons. Lastly, polonium can act as a poison, as it was seen in the murder of Alexander Litvinenko. Polonium is fatal if it is inhaled or swallowed, even in minuscule amounts. Overall, there is no doubt that both radium and polonium have made a big impact on the world today, both in chemistry and in other fields like healthcare.
Now, to get into the chemistry of radioactive decay, we'll go over the different pathways that are possible. Alpha and beta decay are both decay via particles, hence the particles we see leaving the atoms in the top two pictures. Alpha particles are made up of a helium atom, or 2 protons and 2 neutrons. Beta particles are electrons. Gamma decay is different because of gamma rays. This means this radiation is not particle-related, but electromagnetic waves. Hence, the bottom picture is just a wave with no particles involved. Alpha and beta decay are not as strong as gamma radiation, which can pass through 1 meter of lead. This said, polonium, uranium, and radium all use alpha radiation. Radium also uses beta and gamma radiation. How does this all tie together and relate to what we learned in a general chemistry class? Marie Curie's contributions to chemistry helped shape what we know today as the periodic table. First and foremost, by her discovery of elements that were added to the modern periodic table, and also by the principles she helped ground with her research, which led to our understanding of how elements are structured and the way they behave. Specifically, the claim that atoms were indivisible. This was a widely held claim during Curie's lifetime, and her research wasn't the only evidence that helped refute it. It is also important to point out that though we now understand that radiation is due to subatomic particles like protons, neutrons, and electrons, Marie did not know about these particles at the time of her studies. But her conclusions about radioactivity opened the door for scientific understanding about the structure of the atom. This is because radiation meant there was emission of tiny particles from the atom. Along with other experiments from other scientists, the previously thought claim that the atom was indivisible was refuted, and brought to our modern understanding of the subatomic particles that make up the atom. This impacted the field of chemistry in such ways that the possibility for atoms to be rearranged led to the creation of the atomic bomb and development of nuclear energy. With the newfound knowledge about subatomic particles, scientists in the field of chemistry were able to better organize what we now know as the modern periodic table. We now define an element's identity by its number of protons, its chemical behavior by its number of electrons, and its isotopes by its number of neutrons.
To conclude our presentation, I want to leave you all with this quote. I have no dress except the one I wear every day. If you are going to be kind enough to give me one, please let it be practical and dark so that I can put it on afterwards and go to the laboratory. Marie Curie. I found it interesting how despite all of her research and dedication to radioactivity, men could not see past her gender. Regardless of the barriers society placed on her, Curie understood great things come with a great price. Her discoveries touch individuals beyond her time in ways that are unimaginable. Who knows? One day she might save your life. Thank you.